Hey guys, today what I wanted to do is I wanted to go over sig figs with regard to dimensional analysis problems. So on your homework for today, there's this question right here, question number 4, and it asks, how do we determine the number of significant figures in a conversion problem? And there's a couple of different answers. The answers are kind of, well, whatever you start with, that's the number of sig figs your answer should be. Another one says it's got to be 25. 25 is the number of sig figs you need to have. Another one says 3. 3 is the number of sig figs you have to have. And a third one says 1. 1 is the number of significant figures you have to have. And some of the problems on the homework also kind of are trying to get at significant figures. So, for example, this is one of the problems on your homework. You'll have to convert half a cup into milliliters. And so you'll notice that all the math looks the same, where we kind of do a great job of canceling out, cups per gallon. We, of course, know that 16 cups goes in 1 gallon. If you didn't, you learned something new today. So gallons kind of cancel out, or cups kind of cancel out. And then gallons also cancel out because there's about 4 liters per gallon, a little bit less, so 3.7. And then, of course, that we know liters are going to cancel out here because for every, 1 liter, we have a certain number of milliliters. So any good dimensional analysis person would know that we're going to start with, in our calculator, we're going to start with the number 0.500. We're going to divide it by every number on the bottom. So in this case, we divide it by 16. And then we don't really have to worry about the ones here because if you divide a number by 1, it stays the same. So then we can kind of multiply it by 3.785 because that number's on the top. Any number that's on the top, remember, gets multiplied. And so then we'll also multiply it by 1,000 because that's the number of milliliters we have. So this is the math. And then when you actually plug this into your calculator, you get a number like 118.263456145567, or, something along those lines. There's a bunch of decimals after. Now, the question becomes, how many of those decimals do we use in our final answer? So this is why I kind of wanted to ever so briefly review the wonderful world of sig figs. Here's what we know, right? Looking at each number in this calculation, we can see that 0.500 has 3 sig figs. This 5 is significant, and then these 2 zeros are also significant because they're after decimal zeros. They come after the decimal and after a number. So they're all significant, 3 sig figs. 16 over here has 2 significant figures. This 3.785 has 4 significant figures, and this 1,000 here has 1 significant figure. So you might be tempted in your final answer here to think, okay, rules of sig figs say lowest number of sig figs, in this case it's 1, so our final answer should be 100 milliliters. Unfortunately, that is incorrect. The correct answer here would be to say 118 milliliters. Now you might be wondering, why is that? Is it just always 3 significant figures? Well, the answer is actually a little bit more complicated than that. Think about this for a second. In the problem, we said that 1 gallon has 16 cups. Now that's not a estimate. It's not that it could be, like 16.4 cups. It's exactly 16 cups. So this number could be written as 16.0000000000 because it's exact. We know that there's exactly 16 cups in 1 gallon. So here's the thing that we know. It's not that these conversion factors have a specific number of sig figs. Like, for example, we know that there's exactly 1,000 milliliters in 1 liter, so it's really not 1,000. It's, again, we could think about it as 1,000.00000000, because the number is exact, and we could think of 1 liter as exactly, 1 liter with a bunch of zeros at the end of this. So this 16 number has an infinite number of sig figs. This 3.785 has an infinite number of sig figs. This 1000 number has an infinite number of sig figs. So really, our lowest number of sig figs is always going to be the number we start with. So a good way, a really simple way to kind of remember this is that whatever number you start with, however many significant figures it has, that's how many significant figures your answer needs to have. So, to kind of review here, it's not 25, it's not 1, and it's not 3. The correct answer here is A. The answer will have the same number of sig figs as the number we start with, A. So hopefully that clears up a little bit of confusion on when do I use sig figs, when do I not, how many sig figs should I round my answer with when it's a dimensional analysis problem. If you go back to some of the previous quizzes, all of the answers, when it came to number of significant figures, they should have all had the same number of significant figures. As we move forward here, the answers might not. Some might have higher or lower number of sig figs. So not only will you have to get the correct answer, and not only will you have to organize your units so that they cancel out correctly, but now you'll also have to make sure that whatever answer you get, you round it to the proper number of sig figs. So let's go ahead and try one problem where we kind of put all of that together. And the problem we're going to work on is, let's do this one right here. We're going to work on converting 55 grams into some number of ounces. So here we go. We know that we have a couple of conversion factors. We know there's 1,000 grams, exactly 1,000 grams in 1 kilogram. We know that 1 kilogram has 2.201 pounds. And we know that 1 pound has exactly 16 ounces in that. So we're going to use that to help us solve the problem. Let's start off with 55, because that's our number that we're trying to convert from. And the unit that is grams. Since I know that I have 3 conversion factors, I know that I'm going to need 3 kind of sets of parentheses here for this problem. And then the last thing that I know is that since I start in grams, grams are going to need to go right here on the bottom. Okay, well, let's get started. So the first number, the only conversion factor I see with grams is this first one, where it says 1,000 grams equals 1 kilogram. So I'm going to put 1,000 next to grams and 1 next to kilogram. That's my first conversion factor. I did a great job writing that conversion factor down too. But now, I don't need to rest on my laurels right now. What I need to do is immediately, I see that kilograms is on top. That means kilograms is going to have to go, oops, I wrote it wrong. Kilograms has to go on bottom in the next conversion factor. Notice that 1,000 goes on the bottom and 1 goes on the top. Or another way of thinking about it is 1 goes with kilograms because that's what our conversion factor says. And 1,000 goes to grams. Again, that's what our conversion factor says. Sometimes I'll flip these numbers. I'll leave grams on the bottom and kilograms on the top, but I'll put 1,000 next to kilograms and 1 next to grams just to see if you're paying attention, right? So be aware of that. Sometimes these guys might get flipped around. Okay, so then we have to figure out our next conversion factor. We've already kind of used this top one here, so we'll probably use this middle one for the next one. We know that for every 1 kilogram, I have 2.201 pounds. Again, notice how I put 1 with kilogram and 2.20 with pounds. I'll see people flip these all the time just because they don't really know that a kilogram is actually heavier than a pound. Fun fact it is, the ratio is 2.2 pounds for every 1 kilogram. As soon as I put pounds on the top, I'm going to put pounds, LBS, on the bottom. And then I know that for every 1 pound, I have 16 ounces. So again, make sure 16 goes with ounces, not 16 goes with pounds. Last thing I want you to notice here before we start solving, it's not always 1 that goes on the bottom. It's not always the number 1 that goes on the top. It varies. It depends on what number goes with what unit, but you can always say that, for example, if kilogram starts on top here, it's going to come to the bottom there. Or If, pounds is on the top here, pounds has to be on the bottom in the next one. Or kilograms on the top here, has to be kilograms on the bottom there. That's what's going to stay the same every single time. And then it's just an issue of kind of, looking at your conversion factors and making sure that they match up. That 1,000 grams here becomes 1,000 grams kind of down below over there. Okay, so let's get rid of all these dashes, and we're going to solve this problem. So what I'm going to do is I'm just going to kind of show you what I will end up plugging into my calculator. I'll start with 55, and then I'll go ahead and divide that by 1,000. Again, 1,000 is the number on the bottom here. Then I'll multiply that by 2.201. 2.01 is the number on top here, so that gets multiplied. And then I'll multiply that by 16. This is exactly how I'm going to plug this into my calculator. Just like that. I don't have to multiply first and then divide. I don't have to divide first and then multiply. I just kind of do it in the order that it says, in the problem. Just kind of take them one at a time. Remember, the reason you don't have to do one before the other is because of order of operations. Multiplication and division, doesn't matter which one you do first, you always get the same answer. Okay, so when you plug this in, you'll get an answer. I'm not entirely sure what it'll be. Let me go ahead and try this out here. Okay, we're going to take 55 and we're going to multiply it. We're going to divide it by 1,000 and then we're going to multiply it by 2.201 and then we're going to multiply that by 16. And when we do that, you're going to get an answer of 1.936. So I'm going to write that down. 1.936, and I think it was 88. Last step here, most important step, we got to round it. So this number started off here, put this in pink, started off with 2 sig figs. So our answer here better have 2 sig figs as well. In this case, I'm going to keep the 1 and the 9. Those are the 2 biggest numbers. And then the 3 is going to tell me to round down. So it'll be 1.9. So I'll write 1.9. And then please, 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 please make sure you tell me that it's ounces, right? Because that's the unit that I ended in. 1.9 ounces is the correct answer there. Hopefully this helps make some sense about significant figures and also about conversions in general. Thank you guys for watching and take care of yourselves. Have a great rest of your day.